Ooh, what mixed number is between 10 thirds and 11 thirds? Okay, so 10 thirds, 11 thirds. These are, I think these are about 2, right? Um, 3, oh no, 3 goes into 10 three times. 3 and a third, and this is 3 and 2 thirds. So what's between 3 and a third and 3 and 2 thirds? I'm going to show you two ways to think about this. And when I show you two ways to do this, I'm trying to get you like the big picture here. If you like one way more than the other to solve these problems, by all means, that might be the way that you like, and you might not like one of the ways. So I'm just giving you a bunch of tools in your toolbox, and what you do with the tools is up to you. This is equal to 7 halves. We're going to make these all improper fractions. This is going to be equal to 13 fourths. Why am I making them improper fractions? Well, for one thing, these numbers up here are improper fractions. And for another, I think it's going to be easy. What I'm going to need to do to solve this is make sure these all have the same denominator, including these denominators up here. Because fractions are really impossible to compare if you're not thinking in terms of the same denominator. Um, we've got 25 eighths. I shouldn't say impossible. I'll show you something that we can do to compare them in a second on the second take of this problem. 2, 4, what else? 3 is a denominator, huh? Because even though it's not in my answers, it's up there. And then 8. Nice thing is with 2, 4, and 8, I think 8 will work for all of these, 2, 4, and 8, except for 3. So the first number that goes into 8 and 3 is it's 24, right? Because 8, 16 is the next multiple. And 3 won't go into 16, so 24. So let's use that for our denominator. I'm just going to erase this stuff. I was just doing that to help myself find a denominator. All right, 24. So 7 halves is 20 fourths. I'd multiply the denominator by 12, right, to get there. So I got to multiply the numerator by 12, and 7 times 12 would be 84. This one right here is 13 fourths, so I'm going to multiply that by 6 to get to 24, right? 4 times 6 is 24, so multiply that by 6. I'm going to multiply 13 by the same thing. 13 times 6. I actually have this memorized, but you could do it out. 13 times 6, and 3 times 6 would be 18. We carry the 1 up there, and sure enough, we get 78 when we do 6 times 1 and add that 1. So it would be 78 24ths. Whoops, that's a messy 24ths. This one right here would be, again, times 6. 15 times 6 is 90 24ths, so 15 fourths is equal to 90 24ths. And you can tell there's a good deal of arithmetic, right? 15 times 6, you might not know that in your head. And same thing with 13 times 6, or even 7 times 12. Maybe you're not so good with your 12 tables. So good deal of arithmetic. We got to, maybe do that out. And that's why it's important to keep your work organized and maybe use separate sheets to do your work out. But 25 eighths, that's the last one. I think this one's a little easier to do in my head because 8 times 3 is 24. And more importantly, this top factor, I know my 25 table is pretty good because of the fact that 25 is a number we use so commonly in our society with the value of quarters, right? 25 times 3 is 75, 20 fourths. Now the last thing we got to do is make sure that we convert these numbers up here to 20 fourths. So 10 thirds, we'd multiply by 8, right? So it would be 80 24ths. If we multiplied the bottom number 3 by 8, we'd have to multiply the top number, the numerator, by 8 as well. And then this one, the same thing. It would be 88 24ths. 11 times 8 is 88. So in the end, what this problem boils down to is what is between 80 24ths and 88 24ths. And luckily, we can see right here pretty clearly that 84 24ths is going to be between 80 and 88. 78 is not. 90 is too high, and 75 is too low. I'm going to look at this problem one more way, though, and maybe you'll like this way a little better. 3.5, we can clearly say, what a half is and what a half isn't. Can you tell that this is less than a half? Can you tell that this is more than a half? Maybe you know that a quarter is more than a half, right? Because 2 fourths, right? This is really equal to 3 and 2 fourths. I should bring the 3 over too. Let me try to squeeze that 3 in there. There we go. 3 2/4. I shouldn't say this number is equal to it. Let me erase this off. Scratch that from your memory. This number right here is 3 2/4. So you can kind of get the sense that these are pretty far away from. So this number here is 3 2/3. I mean 3 1/3. Keep messing that problem up. This is 3 2/3. You might know off the top of your head that 1/3 is less than 1/2 and 2/3 is more than 1/2. If that's the case, you can probably tell right away that this is between. But besides that, I could make these into decimals. I've got this memorized that 3.5 is 3.5. I know that a quarter is 3.25, and you might have these memorized too. I don't know. I just think of money with these quarters. The only one that's tough to memorize is 3 1/8. So I could do that one out. I know it's going to be 3 point something, right? Numerator would go over here, right? Because it's a fraction. 1/8 is a fraction, and we want to get part of a whole, so we should get a 0 up here. And I'm going to need a bunch of zeros. I actually do have this one memorized on top of my head, but I want to do it out anyway, just to be sure. That's going to be 2. We bring down a 0. That's going to go in twice. And then we'll get 16. And we get 0.125. So 3 in 125 thousandths. I think it might be easiest too to make sure all these have the same number of digits. So I'll just add a 0 over here. I could add 0 to this one, and then 2 zeros to 3.5. So now they're all in the thousandths place. That's easy to compare. 1/3 and 2/3, I have those memorized, but I'll show those too. So again, with 1/3 here, I'm assuming already that it's going to be equal to 3 point something, and I'm just figuring out what 1/3 is as a decimal. So 3 goes into 10 3 times, and we should get 3 going into 1 0 times because the fraction part of this, the 1/3, is less than 1. I mean, we've already assumed that it's 3 point, whatever it might be. So far, 3.3, right? And if we keep going here, you're going to see that there's this decimal is a repeating decimal. 10 minus 9 is 1. We'd bring down a 0. We'd get 10 again. So the 3 is going to be repeating. And so if we did this out to the thousandths place, it would be 3.333. And it's going to keep going. But we know that that number right there, 3.333, that means it can't be this, and it can't be this right here. So you're really only left with 3.75 and 3.5. And 3 2/3 is equal to 3.6, and the 6 is repeating. 3.6, so it would be 66666, and that's actually going to be a little smaller than 3 3/4. So the only answer that, again, that makes sense is 3.5.